I've given you area of layer, correct?
Yes, sir.
Yes, sir.
And if I ask you not to get me first per unit area, but to get me force, you will happily be able to find what will be force on every layer because area remains same, correct? Yeah.
Yes, sir.
Area remains same, area will be given to you and area is same. It is very much within our hand to calculate what that area is. And we can find F is equal to NA dV by dZ anyway being constant, right?
Yeah. Yeah. Yes, sir.
Now, if it is cylinder, are you getting it now? If it is cylinder and then layer being asked, what will you do? If it is cylinder and then layer being asked, I am referring to the question I took yesterday. I told you that I'll be furthering on this question later. You should check in iRodove on what the language and how they have supplemented this question. If it is cylinder, then what will be the area? Tell me. Now can you say that every layer is to be attributed same area?
No, sir.
No,
Can we
sir.
say the same?
No.
Can we say the same that every layer is to be attributed same area? Think about it. Layer,
Okay.
I asked yesterday, what is the shape of layers? You told me. Layers are cylindrical on shape, correct?
Yes,
Yes,
sir. So
sir.
can we take a thing like an average area of all of them?
Yes, I'm coming to that only, dear. Can we say firstly that area for every layer will be same? Of course not.
No, sir.
We cannot. Why? Because area will be, yesterday we wrote 2 pi r into L, correct, dear?
Yes, sir.
Yes, sir.
R is variable over here. We are moving from R1 to R2. Same yes or no?
Yes, sir.
Yes, sir.
You can't say every layer will be attributed same area. You cannot ascribe same area to all the layers being formed. What will I say then? Will I then say, another question, will I then say that layers are to experience different force? Think about it. Will I then say that layers are to experience different force? Can I make this statement? Can I make this blanket perception that layers are now to go for different force application, even if being given they being laminar on flow? The moment it is
Yes,
given
sir.
they are laminar
Yes, sir.
on flow, please remember.
Yeah,
If
yes.
it is given they are laminar on flow, that means there is a specific order followed by them. Getting it?
Yes, sir.
Yes, sir.
Order we cannot disturb. So we cannot say force will change as per position. Am I clear?
Yes, sir.
Then force will anyway for that position also, whichever position we are finding for, will equate itself with the position which we are, if at all, to change. It will not be dependent on position. It will be given by F. That F may not be known to us, may not be given to us, but we are happy in our skin saying F will be constant till the time it is maintaining an order, till the time it is in laminar flow. Getting it, dear?
Yes, sir.
Yes, sir.
Now, Krish did ask me,
Yes.
what shall we do in those cases? The cases being given to us, let's say the question is asking for how is velocity changing? Fine. We know that F will not change. But you
So,
don't ask how is velocity changing? Velocity is changing?
so one
Isn't
small
it?
thing. Yes, sir. So,
Velocity will change or not? Or you will
yes,
say no,
sir.
velocity will not change. It is ordained to change. Why? Because we have attributed to R1 velocity 0 and to R2 velocity V naught or vice versa. Isn't it? We have, yes or no?
Yeah, yes, sir. Yes, sir.
Yes, sir.
Different layers are to move with different speeds. So we cannot be dismissive of change on velocity. Velocity is function of position given. Else dV by dz will be or dr will be 0. Correct?
Yes, sir.
Yes, sir.
So if we change the question and rephrase it to find how is velocity changing with position, then what we should do? Can we go with what Krish did suggest? Can we go with average area? To which my answer will be, if we are going by average area, then we are too selective. It's not that you cannot go with average area, but if it's being given to you that R1 and R2 are distinctly different, are you getting it?
Yes, sir.
R1 and R2 are distinctly different. If that is the language of question, then we cannot go with average area, because if I'm going with average area, I'm of the opinion that V is not changing significantly, correct?
Yeah, so the other approach would be, can we take instantaneous area at that instant?
Yes, we will have to. That is the only way out. That is
Yeah.
the only way out. We'll have to take instantaneous area. So as I have taken it, so let me get to the end of it, and then we'll start. I got again dissuaded anyway. That's an important point which I want to raise, and please don't make light of my ask, because I'll be going vociferous later. And if I go fire and brimstone later, I'm not to be blamed, because I have asked you, forewarned you with many an implore. I'm imploring. Solve questions from Aerodo on fluid. Okay?
Yes,
It is
sir.
important for us to get a good hold on topic fluid. Reason, it has in last 5 year gained grounds. Okay?
Yes.
sir.
So,
Okay.
one
Now
doubt.
look over here. What was given to us the other day? Yesterday we were solving this question. So what do we get to know and how it changes? It's very amusing how it changes with language. This is moving with V naught, and we know that this layer will be at rest, so this is equal to 0. Fine. R1 and R2 we can take. Lamina, we write for any position. We write for any position. What is this to us? R. What we take the area as it indicate, Krish? 2 pi R into L, right, Krish?
Yes, sir.
So area will be 2 pi R into L for this layer, not the rod but layer, correct?
Yes, sir.
And then we write F on the layer as minus of eta 2 pi RL, correct? And into dV by dr, right? Yeah.
So,
dV
the lower part
by
is
dr. We are
glaring,
taking
sir. I'm not able
instantaneous, correct, Krish?
to see the lower part. It's a little glare. Yeah, better now.
Better?
Yeah, yes, sir.
Visible, Krish?
Yes, sir. Yes, sir. Yes, sir. Now it's good.
So F is equal to N 2 pi RL into dV by dr, right? Yeah.
Yes, sir.
Yes, sir.
Now what I am to do, as you have suggested, I am taking the instantaneous area. So instantaneous area taken, and accordingly dV by dr. Yes, we are of the opinion that F is constant. Agreed?
Yes, sir.
And F is ought to be constant. And if F is constant, then can we write this as F divided by N 2 pi, they are all constant. L, correct? They are all constant. Yes or no?
Yes, sir.
And L, they are constant. So yes or no, dear?
Yeah, yes, sir.
Yes, sir.
And then this is to get you dr by r is equal to dv. Agreed? dr by r is equal to dv, right, dear?
Yes, sir.
Yes,
And
sir.
what we can say, this being constant, of course, we have to go for integration, known to all of you. So now we are going for integration, and we know from here we'll get it as a function of r, correct? Yeah.
Yes, sir.
So that is what is required. This part is to be taken constant. Is it okay? And we'll get v as function of r. How we will integrate? Tell me.
It's from so for dr by r, it will be from r1 to r2, and
Okay.
dv
If
will be
I'm
from
taking
0
from
to v.
R1 to R2, if I'm taking from R1 to R2, Krish, then I'll have to take this from V0 to 0, correct? I'm
Yes,
not
sir. Yeah.
negating what you said. I'm not negating what you said, but if I'm taking it that way, then this is R1, correct? This was R1. Please do check. Yesterday, what did I write R1 to be? Was this R1 or not?
So we wrote it as small r and capital R.
Yeah.
So small r was the one of this
R1,
thing.
R2 now, then it's fine with you. This will be R1, this will be R2, fine. Because
Yeah,
see,
yeah,
answer cannot be in terms of unknown. F is unknown over here, correct?
yeah. Yes, sir.
We don't know what is F. Yes, we know it will be constant, but we are not known to its value. And I cannot present in terms of F the answer. That will be incorrect of me to present it in terms of something which the author didn't furnish, correct?
Yes, sir.
Yes.
So we need to know first what will be F. And for F, you have enough avenue. Because you know V0, you know 0, you know R1, you know R2. So this will get you F, correct?
Yes, sir.
If F is asked, you know what F will be. And please make a distinction from what we did the other day. The other day we were calculating on cylinder, right? And
Yes, sir.
this F is on the layer. Every layer will experience same force. If that force is being asked on only the question on what is the force experienced by layer, you got it from here, correct? Yeah.
Yeah. Yes, sir.
So F is gettable. Once F is gettable, you place that value of F and then the limits are to change, right?
Yeah. Yeah.
Yes, sir.
From R1
Yeah.
to
Yes, sir.
R
R1
and
to R.
not to V, correct?
Yes, sir. Yes, sir.
Yes, sir.
Getting it or
So
not,
there's a
class?
yes, sir. So there's a
Yes, sir.
minus sign.
Yes, Krish.
So there's a
Yeah.
minus sign. So won't the limits?
Minus is Krish, minus don't get much bug with minus. Minus is indicative of direction, right?
Okay. Yes, sir.
Minus is indicative of direction. You can take that minus. Okay.
Yes. Yes.
Okay, so I presume you will be furthering it. And please make distinctly clear a point. Examination one side. I will ask for your notebooks when we are back to organic classes, or even if I'm not back to organic classes, because it is, I presume, far cry, at least for coming 2 months, that is not to get established. So after of third test, I'm to ask you to upload each and every page of the notebook which you are following. Is it okay? Not the one which you are following for classroom, the one which you are following for homework. Is it okay?
Yes,
Yes, sir.
And though the questions which I am indicative of, be I Rudo or Estivama, which are must for you to solve, the book should entail those. Fine, dear?
Yes, sir. Yes, sir.
Sir, I don't maintain a book like that. I just solve everything in like one book, all subjects in one book.
No problem, dear. You
I
can take
send those,
snapshots, right, dear?
yes, I send those pages.
Wherever you are solving, be it wall, I solve on newspaper wall, anywhere. So I can take a snapshot, right, dear?
Yes, then okay.
Me
Because
too.
I don't
Sir,
maintain.
I have a book that is maintained by Redo, but not all sums are there. Some of them are solved on the whiteboard. But I do have a book.
Problem. In that case, whenever you are solving, please don't forget just a click.
Yes, sir.
Okay, that you can do.
So, but whatever I've done, I can send those. I have
Yeah.
a big book.
Yes. Okay, because you need to maintain a record. I need to maintain a record.
Yes, sir. Yes, sir.
yes, sir.
Okay, now write down. Simple harmonic motion or SHM. Simple harmonic motion or SHM, which is a special case of oscillation, which is a special case of oscillation, relates to three positions of equilibrium. Relates to three positions of equilibrium, they being A, neutral, they being A, neutral, B, unstable, C, stable.
Yeah.
C, stable. When the tendency of a body, after of getting nudged from its, nudge you right, shove you right, or move you right, your language. After of getting nudged displaced, whatever, after of getting nudged from its position. This should be in bracket. After of getting nudged from its position. So I repeat, tendency of body in bracket after of getting nudged from its position is to return. Is to return to its initial position. To its initial position. Then the body is set to enjoy. Then the body is set to enjoy stable equilibrium state. Then the body is set to enjoy stable equilibrium state at the position under study. At the position under study. To elucidate, let us cite an example, class. And just to elucidate my point, and I will cite an example to you. I'll take an example of gold and marble, right? Yeah. I'll take an example of gold and marble. This is a bowl to me, and this a marble placed at the bottom. Fine.
Yes, sir.
Yes, sir.
Okay, now what you do, you tweak slightly, just show it. Very small displacement, mind you. All the displacements which I am to speak of in this topic are insignificant when taken mathematically. Is it okay? Insignificant. Very small. Very, very small. If you're going on mathematical substantiation, you will not be able to. So very small displacement is what we are to limit our studies to. What I'm asking you of you is, think of a marble placed over here, and you displace it very meager is the quantum of displacement. I cannot show it, of course, but the quantum is meager. Find here?
Yes, sir.
Yeah.
Yes.
Displace it. And when you displace it, what according to you will be tendency of marble shown?
So to
Will
come
it
back to its
try
original position.
reclaim its position? Yes or no?
Yeah,
Will
yes,
it
sir.
try
Yes, sir.
Yeah.
reclaim its position or not? Yes or no? Think about it.
Yes, sir.
Okay, I'm not saying you'll be able to reclaim, but in the pursuit of trying, in the pursuit that it will be in, we'll get a motion, and we are to get some description on that motion. Is it okay?
Yes, sir.
So if there is a tendency of given body to get back to reclaim its position, then the body is said to be in stable equilibrium. Here at this position, the body will be said to be in stable equilibrium. Getting it here?
Yes, sir.
Then comes to us, what do we relate it otherwise? Technically, what we can say, okay, this is very experimental of us to say that there is a tendency, there is an inkling of body to get back to initial position. Okay, we understand it practically, we're understanding experimentally. But mathematically and in the language of physics, what do you mean by having a tendency, having an inkling? What is it exactly? I'm trying to relate it to. Do you remember when I said the body is having a tendency, and accordingly tendency will decide whether we'll add friction or not? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
That tendency was also intangible. That was also experimental, right? Dear?
Yeah, yes, sir.
Yes.
What
Yes.
we mathematically or physically substantiated it with force being unbalanced. Correct?
Yes, sir.
Yes, sir.
Force
Yes,
being
sir.
unbalanced.
Yes, sir.
I told you that tendency means there are forces acting and they are not balanced, correct?
Yes, sir.
Yes, sir.
Exactly
Yes.
on the same line over here. If you are talking of this being stable equilibrium position, Stable equilibrium can refer to energy. Stable equilibrium can refer to energy. When we are dealing with energy topic, I told you that any system or body will always have a tendency to be in minimum potential energy state, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, minimum of course is very subjective because you can say, okay, this is the ball. Now I'm taking the ball itself down. So I'm talking of local minimum. Is it okay?
Okay, yes, sir.
Yes, sir.
Yes.
There is no minimum that you can decide. There is no maximum that you can decide. Whenever we speak of local minimum or maximum. Correct? Yeah. That's the reason
Yes.
we call maxima, minima in mathematics. We don't say minimum or maximum. Correct?
Yes, sir.
Yes, sir.
Okay, so local minimum. Now think of potential energy. This is the ball given to you. Where will this particle enjoy, the marble enjoy minimum potential energy? Of course, at the bottom.
Yeah,
Yes,
yes,
sir.
sir.
Yes, sir. Yes,
Isn't
sir.
it? If there is abyss, then there will be no reed because it is a vertical opening. So you'll never be able to get to the end of it. I am not talking of an abyss, I am talking of there being some bottom to the bowl already given, and that is where when the marble will enjoy minimum potential energy, and minimum potential energy is what we associate stable equilibrium to. Got it, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
Please don't confuse yourself with the term equilibrium. Equilibrium means net force zero. Remember.
So, but then I asked you, sir,
To
like,
relate to only equilibrium. Only equilibrium is to relate to net force being zero. Is it okay, Krish?
yes, sir. So, but then unstable equilibrium, I had doubt. So, because I don't understand. They gave in a question, sir.
No,
Then
that is cliche. That equilibrium there is a cliche. There is nothing called unstable and equilibrium. It is oxymoron, right?
yes,
Yeah.
sir. So that's what I was thinking. So, how is it possible?
Yeah. It's oxymoron. Unstable and equilibrium as well. How is that possible? Right? Yeah.
Yes. So that's what I was thinking. How will you solve the question? Because it's either equilibrium or it's unstable.
Yeah, correct, correct. So what exactly they mean of that word or combination of words is, if you take Krish, a bowl which is inverted, right?
Yes, sir.
And you place a marble atop it.
Hmm. Yes, sir.
Again, net force is zero.
Okay, but then it's
Are you
just one
getting it?
small. Yes, sir. Yes, sir. Got it.
Equilibrium, I told you, you will relate with force.
Yes, sir.
Again, net force is zero, normal upward, mg downward. So it is okay, it is zero, net force is zero. But it is in vulnerable state,
Yes,
susceptible.
sir.
Very susceptible, you can easily nudge it, right there.
Okay. Yes, sir. Yes, sir.
And when you do so, do you feel that it will ever have a tendency to reach a top again?
No, it'll go down. It'll go the other way.
Got there? So
Yes, sir.
that's the reason. It is equilibrium, but it is not stable. It is unstable. Are you getting it? So one
Yes,
is
sir. Yes.
equilibrium to us, and the other is unstable equilibrium to us. And that is what I was referring to. Stable equilibrium, unstable equilibrium. Right there?
Yes, sir. Yes, sir.
Equilibrium is there. It is an equilibrium. No doubt about it. Net force is zero in both the cases, correct?
Yes, sir.
Yes,
Force
sir.
being zero in both the cases, right? Yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
If I nudge, then this particle, this marble will have a tendency to return to its original position. It will try to reclaim. Whereas this will have no such tendency.
Yes, sir.
Correct?
Yes, sir.
So they are in equilibrium. One is stable and the other is unstable. Then comes to us the other one, third one, which is neutral. Now,
Yes.
neutral, what we say about neutral, there is a marble kept on flat surface, let's say. There is a marble kept on flat surface, right here.
Yes, sir.
So
Yes,
if
sir.
it
Yes,
be
sir.
on flat surface, of course, it may, if I squeeze it, then there is no tendency to return, or there is no abhor to return. You can tell, it will depend the way that it has been rotated. So what I do say is there doesn't lie much to us to read in it, but we can say, of course, that there can be a third kind of equilibrium as well. Why to limit to two? There can be a third equilibrium as well, where we don't know what will be tendency of body. It may return, it may not return. Remember a question on spool that we solved?
Yes,
Or
sir. Yeah.
rotation mechanics question which we solved. I told you omega, I told you V, and then I told you one can go zero first and then the body will
Yes,
return.
sir.
Correct?
Yes, sir.
Got it, yeah? So
Yeah.
there is nothing to do with potential energy. Are we doing anything with potential energy? No.
No.
So it is neutral on potential energy. Correct, yeah?
Yes, sir.
Yes,
And if
sir.
it is neutral on potential energy, then the body may not have any inkling to get back or may have inkling. That depends on completely what the dynamics of the body is being tended to you with. Correct?
Yes, sir.
Yes, sir.
That is to us neutral equilibrium. Flat surface, marble being left is neutral equilibrium to us. Fine to all of you?
Yes, sir.
Yes, sir.
Yes.
Stable, unstable, and neutral. These are the three equilibrium that the marble can enjoy. Of the three, the most important one for us is stable equilibrium. The most important for us being important vis-a-vis topic under study, stable equilibrium. Why did I lay this credence to stable equilibrium? I'm laying this credence to stable equilibrium owing to the fact that when you displace it from this position, only then the body will have tendency to reclaim its position, and in the pursuit of reclaiming, it will execute an oscillatory motion.
Yes, sir. Yeah.
Okay, in the pursuit of trying to get back to its initial state, it will execute an oscillatory motion. Getting it there?
Yes, sir.
And that is what we are trying to find much about what kind it is and what we get when we compound it or we put another rider to it. But I'll come to that rider later. I think all of you are convinced with motion being oscillatory, correct?
Yeah. Yes, sir.
Yes.
So oscillatory is a terminology used very often. I'm not going in much detailing on what oscillatory motion is. I'll go into detailing on the second part of it. This is the first fiddle. So I'll go to the second fiddle and then we will study about in detail what is oscillatory as well as simple harmonic motion. Find yeah?
Yes, sir.
Okay.
Yeah.
So firstly, you want to relate this topic to equilibrium. Which equilibrium? Stable equilibrium. Did I say that the body will be able to reclaim its position? No.
No. Yes, sir.
I on purpose did fall or stop short of. I'll say I stop short of saying anything on what is it to eventuate. Correct?
Yes, sir.
Yes, sir.
Okay. You are of the opinion that certainly it will settle. Of course, it will settle because that is what is practical. That is what is practical owing to a term which we call damping, correct? I told you yesterday this term will feature in the topic which is incoming. And now we are in it. SHI. Damping, correct?
Yes, sir.
And damping in general depends on directly proportional. It is to speed, right? We wrote yesterday what is F. F is equal to 6 pi eta RB, correct? Yeah.
Yeah. Yes, sir.
Yes, sir.
Yes, sir.
Proportional to V. Say me yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
F is proportional to V. And if I take speed till the time is speed, will there be damping? Yes or no?
Yes, sir.
So it is to eventuate to settling. Eventually it will settle. That is very practical of us to assume that eventually it is to settle. Correct?
Yes, sir.
On contrary, if you don't take any drag, no drag being experienced. If I say there is no drag experienced by marble, then what you ought to say? If I say there is no drag experienced by marble, then what you have to say? Then you will say it will never settle. There is no damping. So it will never settle. Correct, yeah?
Yes, sir.
And in that case, what will it try to do? It will be always on with the pursuit, irrespective of what is going to be the end result. I'll be on with my efforts. Correct, yeah?
Yes, sir.
Maybe no. Or I'll be looking into result and then doing on contrary to what Gita is to say. Is it so, dear? Say me yes or no. What we do, we are to make effort, and that is what we are entitled to. Correct, dear? Result is not in our hand. Correct? Say me yes or no.
Yes, sir.
Yes.
The best example over here is the marble. Marble may not eventuate to the position that it is aspiring for. And the position that it is aspiring for is minimum potential energy. Say me yes or no.
Yes, sir.
Yes,
It may
sir.
not be, but it is relentless. It is not buzzing. What will it be? Always in pursuit? It will be in pursuit of getting this position. Agreed, dear?
Yes, sir.
Yes, sir.
Unabashedly, it is trying to get to that position. It may or may not, is not its lookout, but the efforts being forever on. And if there is no damping, then it will continue this till eternity. Is it
Yes, sir.
okay, dear? If there is no damping it to experience, then this process will continue till eternity. It will never settle.
Yes, sir.
And that is what we are to study in this topic. No damping. I will not take damping into account. Got it, dear?
Yes, sir.
Yes, sir.
Damping not taken into account, and then bring the second factor also in. I am factoring in the part which I did highlight. We began with the premise that displacement is minimal, correct?
Yes, sir.
So how can I reduce displacement? I can reduce displacement. Which displacement over here? Angular displacement, let's say, theta, let's say. I can reduce theta by taking a large saucer. Agreed? If I take a very large saucer, think about it. By very large saucer, I mean radius tending to infinity. Got it?
Yes, sir.
Radius tending to infinity or curvature tending to zero. Clear?
So will it be
Yeah.
similar to flat surface, no, sir?
Yeah,
If
it
you
will be
take
similar to flat surface. I'm not saying flat surface because that is not to serve my purpose,
Yes,
but
sir.
it will be akin to flat surface. Is it okay, dear?
Yes, sir.
Okay. So taking a large saucer, all of you, visible?
Yes, sir.
Yes,
Taking
sir.
a large radius saucer or zero curvature, tending to zero curvature saucer. Let me place the marble again. Let me displace this marble. This is how I'm displacing the marble. Marble over here. This is then subjected to the forces. They're being marked over here. This marble and this MG, correct?
Yes, sir.
Yes, sir.
Friction. These are the two forces that the marble is subjected to. Correct, yeah?
Yeah.
Yeah.
Yes, sir.
Okay. Now tell me, taking this as our y-axis and this x. Okay, x and y done. This is
Yes.
y-axis, this is x-axis. Got it, yeah?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, let me first take the translational part. I'll come to theta later, but first the translational part. I wish you get me mass into acceleration equation along x direction. Mass into acceleration along x direction will depend on components of force in x direction. Agreed?
Yes, sir.
Yeah.
Yes, sir.
Empty will not have any component in x direction, correct?
Yes, sir.
And
Yes, sir.
normal will have a component which will read n sine theta. Please do check. Check it,
Yes,
dear.
sir.
And
Yes,
convince
sir. Yes,
yourself
sir.
on it. Whatever I am saying, this is n cos theta, and this will be n sine theta. Do you subscribe, all of you?
Yes, sir.
Yes, sir. Yeah.
Write it as is minus of n sine theta, and you know why there is that minus sign placed.
Yes, sir.
Correct?
Yes,
Yes,
sir.
sir.
Yeah. Yes, sir.
So m into ax is equal to minus n sine theta, one equation to us pertaining to x direction motion. Now we shift our focus to y direction. Got it, yeah?
Y direction. Yes, sir.
Ay next. M into ay is equal to n cos theta minus
Minus
mg.
M. Yes, sir.
Yes, sir.
Now if the saucer is large, then there will be no significant displacement along y direction. Agreed?
Yes, sir.
If
Yes,
the velocity is large, then there will be no significant displacement along y direction. Agreed or not?
So one question:
Yeah.
won't there be centripetal
Yes.
acceleration in this if it's moving
Yes,
around
dear.
the? So won't there be centripetal acceleration in this?
See, centripetal acceleration depends on v square by r, right, Krish?
Yes, sir.
And what is r?
Okay, okay, yes, sir. Tending to
R is
infinity.
finite, I told you, right, dear?
Okay, yes, sir.
That's the reason we have not incorporated it. Good question, by the way, right, dear?
Yes,
Okay. Over here, m into ay is equal to n cos theta minus mg, and I was on what will be y? Y being insignificant. Do you approve of y being 0? Ay, not ax. Ax will not be 0, mind
yes,
you.
yes,
Why? Because howsoever small y be, x will be large. Just think about the situation that I'm showing. I'll show you a situation. The situation which is at disposal, not very to me what I want to show it is to serve, yet it will to some extent. This is y, right?
yes, sir.
yes, sir.
This is displacement along y direction, and compare it with, contrast it with displacement along x direction. Please see for yourself. Contrast it with displacement along x direction, right? Yeah.
Sir.
Yes, sir.
Yes,
And this is for which case? This is for a case of finite radius. I have drawn a saucer of finite radius. If you take radius to be infinite, think there will not stand any comparison between x and y. Agreed or not?
Yes, sir.
yes, sir.
So y being 0, we can take ay 0, leading us to a conclusion n cos theta equated to mg, correct?
Yes, sir.
Yes, sir.
Yeah.
And using this in our first equation, we get m into ax is equal to replacement for n now class. N is mg by cos theta. So what do we get this as? Mg tan theta. Agreed?
Yes, sir.
Okay.
Normal will replaced by mg cos theta, mg by cos theta, and sin theta already out here. So mg tan theta. Agreement, all of you?
Yes,
Come on.
sir.
Yes,
Okay, clear.
Yes, sir.
Check it out. Check it out. Don't worry.
1 second. Yeah.
Yes, sir.
Yes, sir. Yeah.
Okay. And then we get ax as g tan theta. Look at the right angle triangle here, class. This is 90 degree, right here. So look at this
Yeah.
right angle triangle and tell me that if I write tan theta as x by r, will you approve it or not? If you are purist, you will say it should be marked x by r minus y, correct?
Okay.
yes, sir.
Tan theta should be marked x by y minus, sorry, r minus y. This will be r minus y, correct?
Yes,
Yes,
sir.
sir.
Yeah.
And
Yeah,
r
yes.
is the radius. But we are of the opinion y being insignificant, correct?
Yes, sir.
Yeah.
What we can zero it down to is g into x by r. Fine, all of you. This is what we can zero it down to, correct?
Yes, sir.
And on the
Yes, sir.
side. Minus also we have to carry along. Check it out. Is it okay?
Sir.
Minus we are carrying, correct?
Yeah. Then okay. Yes, sir.
Yes, sir.
Okay. Now make some observation, class. Make some observation here. Observation number 1. Is acceleration proportional to displacement? I'm referring to
what is-
AX.
What
AY
is R
doesn't
here,
know
sir?
AY 0.
Yes,
Yes,
sir.
Krish.
What is R here?
R is the radius.
Okay.
Radius, which is very large. It is
Okay.
very large. Isn't it, dear? So much so that we have negated y in comparison to r, correct?
Okay. Yes, sir.
Okay. So r is a radius to us, and I'm asking you of two observations. Observation number 1. Can we say acceleration is directly proportional to x, or acceleration is directly proportional to displacement?
Yes, sir.
Yes,
Yes,
sir.
sir.
I'm saying acceleration, I'm not saying AX. Why? Because AY is 0. So be it AX or A is same to me, correct?
Yes,
Yes,
sir.
sir.
So acceleration is directly proportional to displacement. And the second observation, it is opposite in nature. Minus sign. Minus over here is indicative of nature, correct here? It
Yes,
is
Yes,
sir.
sir.
opposite in nature. If displacement is to the right, acceleration will be to the left. That is what it suggests. Is it okay?
Yes, sir.
Yes, sir.
So, acceleration is directly proportional to displacement and is opposite in nature. If we get to meet such a scenario, if we meet such a scenario in which an oscillatory motion is having acceleration which is directly proportional to displacement and opposite in nature, got it here? Which is directly proportional to displacement and opposite in nature, then this oscillatory motion comes under a subset, and that being, it will also be called simple harmonic in nature. Got it here? I'm not taking away from fact that it is oscillatory. It remains oscillatory, but an extra feature is getting added to it. And what that being? Acceleration is directly proportional to x and opposite in nature. Got it here?
Yes, sir.
Yeah.
So this oscillatory with this part, this feature being addition to it is then calling for another name. And what it is calling for another name, I'll get to know after some time. But for now, it calls for another name. It is being superseded. And this name is to us in short SHM, full form being simple harmonic motion. Fine, yeah.
Yes, sir.
Yes, sir.
Yeah.
But we are transcending the barrier of oscillatory motion. We are going into the special feature of oscillatory motion. And that special feature over here being acceleration vis-a-vis displacement relation, correct?
Yes, sir.
Yes, sir.
Yes, sir.
So I see a periodic motion and oscillatory motion can be anything. I'm moving outside, I'm coming in. I'm moving outside, I'm coming in. That is what motion to be a periodic motion, right here?
Yes, sir.
Yeah.
Yes, sir.
Okay, because I'm repeating my position, I'm repeating my speed after some time, and that time you can easily calculate in mathematics what we do. We calculate it as fx is equal to fx plus t, and t will be the period. So that is what we do in mathematics. Period can be calculated for any motion which is in repetition. Correct? Yeah.
Yes, sir.
Yes,
That
sir.
is movement which is in repetition, only repetition, without being any further addition to it, will not or may not qualify to be called a simple harmonic motion. Got it, yeah?
Yes, sir.
For a motion
Yes,
to
sir.
qualify being called simple harmonic, acceleration, it should be periodic, of course, it will be periodic, but acceleration should be directly proportional to displacement and opposite in nature. Got it, yeah?
Yes,
Yes,
sir.
sir.
Okay. With this, we further. Okay, so quintessential, please remember. For SHM, what is quintessential? Quintessential being acceleration and displacement relation. Got it, yeah?
Yes, sir.
Yeah.
Never confuse simple harmonic with periodic. All the simple harmonic motion are periodic nature, but the converse is not true, correct?
Yes,
Yeah.
Can we say that? Yes or no?
yes, sir.
Yes.
Okay. With this being nailed, let us further. Write down. As acceleration can be represented as V into dV by dx. Now we are qualifying our statements here, right? Yeah. This was
Yes,
a
sir.
statement made. Let me qualify that statement with an equation. What I'm changing A by is V into dV by all of you.
Yes, sir.
And I
Yeah.
think this is not new to you. I don't think anyone is green on to this equation. If you are, just recollect, dv by dt
Yeah.
is what acceleration, correct?
Yes,
Yeah.
sir.
And this can be marked as dv by dx into dx by dt, right? Yeah.
Yes,
Yeah.
sir.
Yeah. Yes, sir.
And dx by dt is what to us? Is nothing but v to us. So v into dv by dx, correct?
Yes, sir.
Sir.
Yeah.
dv by
Yes,
dt can anyway be changed anytime we change to v into dv by dx or v into dv by ds, correct?
Yes, sir.
Okay. To my suit over here, v into dv by dx. And what is this to me? We'll be equating it to minus of g into x by r. Good, yeah?
Yes, sir.
Okay. Just rewriting it, nothing much. Minus of g into x by r, this equation. Okay. So minus of g by r into x. Now,
Yeah.
g by r is a term which is subject to experimentation setup. G by R is a term, Krish,
Yes, sir.
Vedant and Adesh, which is subject to experimental setup. By that, what I mean, if I have this setup, I get it as G by R. If I have another setup, I may get it in consonance with that setup. So what I want to do here, I want to liberate myself of this beholding. Is it okay? I'm beholden by setup, correct? Yeah? In
Yes,
order
sir.
to know
Yes.
what is T by R, I am beholden by setup. So let us liberate ourselves. Let us free ourselves of this setup concern. And to free ourselves, what we do, we use a term omega square. Got it?
Yeah.
Now, omega, what will I say now comfortably? Omega is subject to system. Clear here? I will now comfortably say omega is subject to system. If I change system, omega will change to make my equation generic. Instead of writing g by r, what I am writing over there is omega square. That means what is omega in this case for this system? Under root of g by r. Got it, yeah?
Yes, sir.
Okay, so it is just to make it generic. Here also you can use ax is what to us? Ax is equal to minus of omega square. This will make this equation generic, correct?
Yes, sir.
Okay, dear. Say yes or no. I want a resounding yes on this.
Yes, sir.
Oh,
Yes,
yeah.
sir.
And omega is called angular frequency. Then what is omega called here? Omega is called angular frequency. Please don't call it angular speed. We have used the same abbreviation for angular speed. It is not angular speed, though there is a relation between angular speed and angular frequency. I'll come to it later. For now, to begin with, it is called angular frequency. Got it here?
Yes, sir.
Yes, sir.
Yes,
So
sir.
omega to us being angular frequency, I'm using omega here as well. Tell me, can we rearrange it to minus of omega squared x dx? An issue?
No,
Yeah.
sir.
dv is equal to minus of omega square x dx. Got it here?
Yes, sir.
And then we
Yes,
can
sir.
go for integration. Shall we?
Yes,
Yes,
Then
sir.
we go for integration. So going for integration will lead us to the dependency of V on X. Let us go for integration. It will reveal how is V dependent on X. Please see for yourself. V dV will be V square by 2 when integrated.
Yes, sir.
V dV will read
Yes,
V
sir.
square by 2 when integrated. Yes or no?
Yes,
Yes,
sir.
sir.
Okay. And to the right, what you have? Minus of omega square intact. That is system concern. Omega won't change for a given system. Correct? Yeah.
Yes, sir.
And x dx when integrated will get us x square
X
by 2.
square by 2.
Correct?
Yes, sir.
Yes, sir.
If I'm taking indefinite integration, I'll have to put a constant of integration. Right? Yeah.
Yes, sir.
Yes, sir.
Then
yes, sir.
constant integration is c to s. Okay, to all of you?
Yes, sir.
Yeah.
Okay, now tell me what was the nature? The nature which I did enunciate. Could you please elucidate to me what nature is this motion of? Is this motion of nature where acceleration is always opposite to displacement? Yes or no? Yes or no? Tell me. We
The
have
acceleration is always opposite to.
equal to minus of omega square x, and you made two observations. I'm now asking you on the application of these observations. Observation number one. Tell me, is it correct or not? Did we take acceleration being in direct proportionality with x? Yes or no?
Yes, sir.
Yeah.
And opposite in nature.
Yes, sir.
Yes, sir.
Yeah.
So if acceleration is opposite in nature, opposite to displacement, don't you think that there will be a time when body, though momentary, will come to rest?
Yes, sir.
Acceleration, I'm going to the right and acceleration is left. Acceleration left means someone is pulling me from left. Getting it or not?
Yes, sir.
I'm going
Yes,
right and acceleration is to the left. Means someone is pulling from left. Correct? Yeah.
Yes, sir.
So what happened? As I'm moving forward, I am trying to negotiate with this pull, correct?
Yes, sir.
It may be possible for me to overcome this pull. And I keep on moving in the forward direction, right, dear? It may be possible that I'm able to overcome it and I'm moving in the forward direction. Fine, dear?
Yes, sir.
Yes,
But
sir.
then what's
Yeah.
the problem? The problem is this pull will increase with x. Are you getting it?
Yes,
What
sir.
did you get? Acceleration is proportional to x. Say yes or no?
Yes, sir.
So if I'm moving more and more to right, what will happen to pull? Pull will increase. First it is a pull. Pull means what? Negative sign. Getting it?
Yes,
Like a
sir.
spring, no, sir.
Yes. First it is a pull, which is negative. And second, as you are moving further, what is that person to do? To apply more force on you. Getting it?
Yes, sir.
Yes, sir.
So is it not incumbent on you to get a point where you will come to rest, though momentary, but you'll have to come to rest? Think about it.
Yes, sir. Yeah.
So we will come to rest, and after coming to rest, what will happen? I will give in to the pull. Correct?
Yes,
We
sir.
are giving into the pull. And if we are giving into the pull, we'll start retracting, retracing. Correct?
Yes, sir.
So after stopping, I'll retreat. Can I say?
Hmm.
Can I say yes or no, dear? Think about it.
Say-
After stopping, what will happen? I'll retreat. I'll start moving backwards. Fine?
Yes, sir.
Yes, sir.
Okay. So I'm asking of, will there be a maximum of x? Yes or no?
Yes, sir.
Yeah.
And at that maximum x, what should be v?
So
Zero.
maximum.
That maximum
Minimum,
x,
minimum,
what should
minimum.
be v? Come on, dear.
Minimum.
So minimum. Minimum.
What
Minimum.
that minimum value
Zero.
be?
So zero. So zero.
Zero. Say so. Zero. That v will be zero. V speed over here will be zero. So the value of x at which v is zero is called amplitude. Is it okay, dear?
Yes,
Is
sir.
called
Yes, sir.
amplitude. So in a way, amplitude is maximum value of x. Can we say that?
Yes, sir.
Yes,
Can we
sir.
say that or not? Maximum of displacement. Say me yes or no, dear.
Yes, sir.
Yes, sir.
So could you explain it
Okay.
once again, sir?
X, yeah. Dinesh, you're saying something. You're asking something. Yeah, tell me.
Sir, could you explain it once again?
I said that let us take a scenario in which there is a spring which is connected to block. And then what you do, you displace it and release it. Find ya?
Yes, sir.
So when you are pressing it, let us say you have applied force and spring got compressed. Fine.
Yes, sir.
So spring got compressed and then you let the system fend for itself, right? What will spring
Yes,
do?
sir.
Will try to get back to its original shape, so apply force on block, right? Spring force on block, agreed?
Yes, sir.
Block will start moving to the right. That is good with us. Okay, block is moving to the right. Spring force to the right, block is also moving to the right. Find here.
Yes, sir.
Okay. Now think of a situation where spring is going beyond this line. Okay? Or block.
Yes,
Not
sir.
spring, block is going beyond this line. Correct? What will spring
Yes,
force
sir.
try to do? The spring force will apply force in which direction? Leftwards.
Yes, sir.
And block is moving to the right. Correct, yeah?
Yes, sir.
Will
Oh,
there be a time
yeah.
when spring will come to rest? Yes, sorry, block will come to rest. Yes or no?
Yes, sir. For a moment.
The time I'm referring to. And why will that happen? Owing to the state, acceleration or force is in the direction opposite to displacement, correct?
Yes, sir.
Yes, sir.
Yeah.
So as acceleration is opposite to displacement. Acceleration means force, dear. Force. Which force? Spring force. Force and acceleration are ought to be in same direction. So force is to the left on this block in this state. So will be acceleration. But the block was moving forward, right, Adesh?
Oh, yes, sir. Understood.
So block is ordained to come to rest, though momentary, but block will come to rest. Same yes or no?
Yes, sir.
Okay. So that is what I'm referring to. I'm referring to a state in which acceleration is opposite to displacement. Got it, dear?
Yes, sir.
And if acceleration is opposite to displacement, then there will be a time when speed will take a null, zero value, correct?
Hmm. Yeah.
Yeah, yes, sir.
Take zero value, then that will be the maximum value of displacement. Block was moving to right, to right. This is x is equal to 0. It was moving to right, and then it stops. It stops over here. Got it here? What
Yes,
is
sir.
v over here? 0. After of this, how will the block move? Tell me.
So it will be
Sir,
retracted.
To the
come back. It'll come back to its
yeah,
original
right
position.
here. So it will be this will be the speed with which the block will move, direction of velocity backward. So is this not the maximum displacement of block?
Okay, yeah, understood.
That is what is given a name, an epithet. It is called amplitude. Got it?
The
Yes.
maximum display. Yes, sir.
Yes. So that is maximum of displacement. Find here.
Yes, sir.
Oh, yes, sir.
Okay, now I'm making some space for myself. Maximum on displacement. Let me say that being written A, V being 0, minus of omega square A square plus C. 2 will go to this side by 2. This is what we are getting C right here. Check it once.
Yes, sir.
So placing this value, we get V square by 2 is equal to minus of omega square x square by 2 minus of omega, sorry, plus of omega square a square by 2. Please do check. I have just replaced for C. In C, in lieu of C, I'm writing omega square a square by 2, where all of you are aware of the symbols. Omega is angular frequency, x displacement, and a
Amplitude.
Amplitude.
the maximum displacement. Correct? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
Now we get the final equation as minus of omega square x square minus a square. So the bracket is negative, so we can write it as omega square a square minus x square. Whichever way you do, this is v square, correct?
Yes, sir.
Correct?
Yes, sir.
Yeah.
So it will be plus minus omega under root of a square minus x square. Got it, yeah?
Yes, sir.
Is visible? Last line?
The last line is
Sir,
half.
last line is not.
Okay, I'm writing it over here. V is equal to plus minus omega under root a square minus x square. Got it, yeah?
Yes, sir.
Yeah.
Okay. Is V to us? V is nothing but dx by dt. Remember?
Yes, sir.
Yes, sir.
Write v as dx by dt as well. And if it is so, let us take one of the two signs out here. Anyone you can go with. I'm going with positive. A square minus x square. And then we rewrite it is we want to integrate, we are looking for integration. So let us go by variable separation method. A square minus x square is what to you? Omega into dt, right? Check it out.
Yeah. Yes, sir.
Okay. This
Yes.
will now be integrated. Integration. What is this to get me? Integration of a square minus x square under root. It will be too ambitious of me to ask, is it so?
No, so we can try.
Ambitious of me to ask, or is known to you? Krish, will you labor me out on this one? What is
Yeah, I'll
integration
try.
of a square minus x squared?
I'll try. I'm not very sure. So I'm not very good at integration.
No. This should not be the case. Sine inverse x by a, right?
So,
Sine inverse x by a. And omega we know being constant for a system, the right is to get you omega into t. Are we complete? Is it completed?
So
no,
how
it has
does sine
constant.
inverse come?
No, it is not completed. Why so? Yes, Krish.
So it
Why
had
it
a
is not
constant.
completed?
The constant of integration.
Yes, constant of integration. Let
So,
me put phi. Phi is
So
the
how did
constant of
sine
so how
integration.
come?
did
Yeah.
sine come? So how did
Yes,
sine
dear.
come in the equation?
Yes, dear.
So how did sine feature in the equation?
This is integration of a square minus x square value, dear.
Oh,
This is what you get when you integrate a square minus x square, sine inverse x by e.
So if
okay.
you're not started
So we
integration,
just
well,
take it on face value and remember it, right?
We, of course, let alone physics, even in mathematics, they will not tell you. How do you get it? Okay.
Okay, yes, sir. Yes, sir.
Okay. Yes. There are few functions which we do show, and that is called first order integration. For example, I showed you, Adesh, if you remember, y is when x square differentiated, we get 2x.
Yes, sir.
Okay, so that is called first order integration or first order differentiation. But a few we are to take on face value, because this to show must, if you want me, then I'll have to go for Fourier series. Just type on Google what is Fourier series, and there you'll get to know how can sine theta be expressed in x.
Yes, sir.
Okay. And from there we get to know that integration of this term is sine inverse
So
x by a. Anyway, that indulgence for preparatory course is not required. So did not go for those, right? Yeah.
yes,
Otherwise,
Yes,
you
sir.
will go for the forum wherein it will be for 4 to 5 months only to understand that time is not a constant. Length is not a constant. All are to change. Time cannot be simultaneous as well. In one clock, somewhere is showing X time, the event took place. In the other clock, at different time, that the same event will take place. So the relativity theory itself will take 5 months to understand, and in 5 months, the entire of physics will go topsy turvy.
Yes, sir.
Okay,
Rajat,
limited to all we have to study. Yeah, Krish.
so what is correct time then? So what is the standard on which all our times are based on?
There is no standard for time. Time is relative.
Okay, yes, sir.
Okay. If you
Like,
start speeding, see, time is moving with some speed, correct?
yes, sir.
Time is moving with some speed. Suppose you start running towards a train, then train will appear to move slowly, correct?
Yes, sir.
So if you start running in the direction of time, let's say we fix the direction of time, time is going somewhere. If I start running in the direction of time, then time will move slowly, slower than previous. Got it
Yes,
here?
yes,
And
sir.
if
yes,
you constant speed of time, then you will be able to see event incoming. That
Okay,
is what is called time travel. Got
yes,
it?
sir. Yes, sir.
Yes.
Be able to predict. You will be able to see what is incoming. Future will be visible to you.
Okay.
So that is time. When we are talking of time, time dilates. Time dilates and length contracts. If you start moving with speed of time, then time will dilate and length will contract. Rest length is the maximum length. If length starts moving, then length will shrink. The same rod will measure less to you on length. Anyway, those are different fora altogether. Let's not go there. It will be very interesting and will draw you. I don't want you to be drawn by it. So sine inverse x by a is equal to what to us? Omega t plus 5. Correct? Yeah. So x
Yes.
by a is what to us? Sine of omega t plus 5. Correct?
Yes, sir.
Yes.
Then x is what to us? A sine of the angle omega t plus 5. This is the basic simple harmonic motion equation. Where what is x? X is the displacement. Please write it down. Where x is the displacement measured from mean position. Where x is the displacement measured from mean position. What do I mean by mean position? Another very important concept. Another very important concept. Why I'm saying so, a student never do understand what is mean position. So for once and for all, to nip it in the bud, remember, mean position means where net force is 0. Okay?
Yes.
Yes.
What is mean position to us? The position where net force is 0. Clear?
Yes, sir.
Or a position where acceleration is 0. Correct?
Yeah. Yes, sir.
Position where acceleration is 0. That is what is meant by mean position. So x is equal to a sine of the angle omega t. A you know, omega you know, phi you don't know. Phi over here is called epoch, E-P-O-C-H. Write it down. E-P-O-C-H, epoch. And the argument, we call in mathematics this term as argument. Got it here? This term
argument
is called argument. The argument in physics is called phase angle or simply phase. P-H-A-S-E. Phase angle or simply phase. Is it okay?
Yes, sir.
Okay. And going by this statement, we can say phi will be called phase angle at t equal to 0. Correct, dear?
Yes, sir.
Yes, sir.
Phi will be called phase angle at t equal to 0. Right, dear?
Yes, sir.
Yes.
So phi is also called initial phase. Got it?
Yes, sir.
Yes, sir.
Phi is also called initial phase. Okay, so everything about this equation is now in your know. X is the displacement and we measure displacement always from mean position. X is equal to a sine of the angle omega t plus phi. And we began with something we should never lose sight of. I write it here for you again. A is equal to minus of omega square x. Correct, yeah?
Yes, sir.
Yes.
Can I end the class with one question? And the question being, what's the time?
Sir,
So
11:22.
11?
22.
22, okay. I'll end class with one question, Krish. You
Yes,
have
sir.
class, right, Krish?
Yes,
School?
I have 11:30.
Okay. So I'll end it with one. I respect the school classes. Why? Because in my place, I am taking your class, my wife is taking school class, my son is taking school class. So that should not be missed. And you know, I lay umpteen curtains to your school certification than any other institutes. Right?
Yes.
A is equal to minus of omega square x. Let me tell you, A is equal to minus of omega square x plus C or 5 if it's 5.
Okay, question is.
This is the equation given to you. what are you to then about this equation preempt? Will it get you a simple harmonic or non-simple harmonic periodic motion? Is it a
So A
simple
stands for
harmonic?
amplitude, right?
Yes, Adesh.
So A stands for amplitude.
A is acceleration, no dear. Capital A is for amplitude.
Okay, yes, sir. Acceleration.
You have already written, yeah. This
Yes,
A you
sir.
have
Sorry.
already written. The previous equation, check here. Check Adesh.
Yes, sir. Capital A. That's why I was getting confused.
That is the equation. I have just supplemented it with 5. I have
Yes, sir.
qualified the previous statement with +5. And then a question. Will this also indicate simple harmonic motion as did this? Yes or no? Is that equation 2 to indicate simple harmonic motion? Any one of you? Take the lead, please. Krish, will you extend the courtesy?
Yes, sir. So I guess yes, it must.
Okay, Adesh.
So once, yes, sir. When I'd say it does.
Oh, yeah. Yes, sir.
Sorry, Vedant.
Is it?
Yes, sir. I'm with them.
Okay. So what do we get over here? We can write it as d square x dt square d square x dt square idea is equal, and many
Yes, sir.
mathematics teachers use their own writing a statement for it. Remember, the correct statement for this symbol is d square x by dt square. Always call it the same way, d square x by dt square. Got it, dear?
Yes, sir.
So minus of omega square x plus 5. Now, what I ask you to do is to take minus of omega square outside. You are left with x minus 5 by omega square. Correct, yeah?
Yes, sir.
And we can write it as d square x minus 5 by omega square divided by dt square is equal to minus of omega square x minus 5 by omega square. Please do check. This and this are same. Why? Because 5 by omega square is a constant. Correct?
Yes, sir.
Yes,
Yeah,
sir.
okay. Yes, sir.
Similarly to Adesh and Vedant. This and this, they are same. Reason, if I expand it, I get d square x dt square and d square 5 by omega square dt square, correct?
Yes,
Yes, sir.
sir.
Yes, sir.
And d square 5 by omega square by dt square will be 0. Reason, 5 by omega square is a constant, correct? Yeah.
Yes, sir.
Yes.
Yes, sir.
So what we can say about this equation is d square zeta by dt square is equal to minus of omega square zeta, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
And this is nothing but a changed form of this equation. Instead of x, I'm using zeta, right? Check it
Yes,
out.
sir.
Instead of
Yeah.
x, I'm using zeta. So they are same to us. Therefore, as all of you did say, this equation also is to represent simple harmonic motion. Got it, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
Direct proportionality being often used, it can confuse you. So this equation also is indicative of simple harmonic motion. But tell me, is there no distinction between these two? Are they same on all aspects?
No, sir.
Mm,
There is one difference you can cite easily. There's one difference which from board you can cite very easily. That one difference is on anyone?
so is it zeta and x? That is the only difference.
Zeta and x, but what is that to be comprehended to? What will you comprehend that symbolic difference to? Zeta and x are symbolic difference, right? Yeah, tokenism, correct? Yeah.
Yes, sir.
Yeah.
What will you, in your deciphering, what can you say is zeta to indicate and what x to indicate? So if you decipher, Krish,
Yes, sir.
this will get you acceleration 0 when x is equal to 0, correct?
Okay, yes, sir.
Yes. Yeah.
This will also get you acceleration 0 when x is equal to 0, correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
Rather, this will get you acceleration 0 when zeta is equal to 0, right? Yeah.
Yes,
Yes,
sir.
sir.
Theta equal to 0 means x is equal to 5 by omega square, correct?
Yes, sir.
Sir.
Yeah.
Yeah. So x is equal to 5 by omega square. Getting it or not?
Yes, sir.
Yes, sir.
Same you can get from here. Put acceleration 0. What do you get? X as 5 by omega square, correct?
Yes, sir.
Yes, sir.
So what are they to be distinguished on? Mean position. Got it, yeah?
Yes, sir.
Yes, sir.
What
Yes,
are they
sir.
to be distinguished on? Mean position. For this mean position is x is equal to 0, and for this mean position is x is equal to 5 by omega square. Got it, yeah?
Sir.
Yes, sir.
Got?
Yes, sir.
Yes.
Yes, sir.
Okay, so that is the distinction which I wanted to bring forward. Anything that you wish to ask?
No, sir.
Or shall we call it a day then?
Yes, sir.
Yes, sir.
Sir, just
Okay.
wanted to inform you, sir. Tomorrow I have an Allen test, sir. So it'll start at 2 o'clock.
Okay. You just pass on. I'll see how it is getting juxtaposed. Accordingly, can keep or cancel. We'll check that.
Yes.
Pass the exact timing so that I can take up all of the accordance. Fine.
Yes.
Sir,
Yes.
so I'm leaving, sir. Thank you, sir.
Thank you, dear. Thank you, all of you.
Thank you,
Thank you.
sir.
Yes, sir.
Thank you.